Welcome back, fellow math enthusiasts. We're going to continue on, as we have been in the last couple contest videos, with the 2013 Csmc paper. We just finished up question 1 in the B part. That's the written portion where you need to justify your solutions. So we're on to question number 2, and we're still going to need to justify our answers. So let's take a look at the question now. Alright, so it looks like it's a 3-part question, unless there's something on the next page, which there isn't. So, A part, expand and simplify fully the expression a minus 1 times 6a squared minus a minus 1. So on expand and simplify, we're going to get a single polynomial, and from the looks of things, an a and an a squared here, we're going to be looking at a cubic polynomial. Okay? And all we're asked to do is expand and simplify. Okay. So a minus 1, 6a squared minus a minus 1. Well, we just use FOIL or whatever other technique you want. We do a times this plus a times this plus a times this. So 6a cubed minus a squared minus a. And then we do negative 1 times this plus negative 1 times this plus negative 1 times this. That's minus 6a squared plus a plus 1. So we expanded, now we need to simplify. Well, this a and this a, they're going to cancel out. And this minus a squared and this minus 6a squared, they're going to come together to give us minus 7a squared. There's no a term, there's nothing associated to a, so we just jump to the 1. Okay. And that's our final answer for A part. Very simple. I'd say it's probably worth a mark. And we're probably going to use this polynomial later on in the question for bigger and better things. Okay. Determine all values of theta with 6 cos cubed theta. So that's cos theta cubed, as they mentioned down here, minus 7 cos squared theta, so that's cos theta times cos theta, plus 1 equals 0. And we're asking for the bounds that theta is between 180 degrees and negative 180 degrees. Round each answer to 1 decimal place where appropriate. So likely we're not going to be dealing with not all the theta values are likely going to be the fun, easy values like 90, 60, 45, 30, and 0, which is why they're asking us to round where appropriate. If we can give exact answers, we should still be giving exact answers. But, yeah, so this question's a tad confusing or scary to look at in the just from the get-go. And the problem is, well, it's a polynomial in terms of cosines, and that's, you know, we're used to maybe cos squared plus sine squared equals 1, that sort of stuff, but never solving something in terms of cosines. But let's take a look. We have 6 cos theta cubed minus 7 cos theta squared plus 1 equals 0. Well, that's very similar to the polynomial we just figured out. We had, in the first part, part A, we had 6a cubed minus 7a squared plus 1 equals, well, not equals 0, but that's the formula we had from this polynomial. So if we were to let a equal cos theta, we'd get the exact same formula that we did in the first part. And we could factor it or use the quadratic formula on this half and try and find where it could be 0. So we can redefine cos theta as a. Okay, so what does that turn this into? It turns into solving 6a cubed minus 7a squared plus 1 equals 0. The exact polynomial we had in the first part, and we know we can factor it. into a minus 1, 6a squared minus a plus 1, or minus 1 equals 0. Okay, so that tells us either a minus 1 either that's equal to 0 or 6a squared minus a minus 1 equals 0. We have those two possibilities. Now this first one we can easily rearrange and say a equals 1. And then knowing what a is, we can solve for what theta is, and that's what we're asked for. And for the second one, we can use the quadratic formula to figure out roots and solve for what a's give that equal to 0. And then at that point, once we have a value for a, we can bring out our calculator and use the arccos function and solve for theta. So this first scenario, a minus 1 equals 0, that tells us that cos theta is going to be equal to 1. Okay, well what values between negative 180 and 180 give us a value of cos theta is equal to 1? Okay. Well, 0. 0 is in fact the only one that will work. You can either do that with your calculator, although if you do it with your calculator, you're going to have to double check because, for example, if you do arc sine of 1/2, you'll get 30 degrees out, but there's also another potential answer, which is 150. So you're going to have to be careful if you do it with your calculator, but if you are a little more familiar with trig functions, you'll know the only possible solution here is theta equal to 0. That's the only one that will work in the given range. Theta equals 360 would also work, or theta equal to negative 360, but we specifically want within the range negative 180 to 180. So how about the other side, the other possible factor, 6a squared minus a minus 1. We use the quadratic formula. So that's a is equal to negative b, so that's negative of negative 1 plus or minus square root of b squared minus 4ac all over 2a. So that's 1 plus or minus, and we get 1 plus 24, so that's 25, so we're going to get a nice little fraction here. Finish up on the other side over here. All right, 1 plus 24, that's 25. Square root of 25 is 5. Oh, sorry. Not square root of 5. We're just going to have a regular old 5. So then a is going to be equal to 1 plus 5, which is 6 over 12. So that's 1/2. Or it's going to be equal to 1 minus 5, so negative 4 over 12, so negative 1/3. Right? And we could double check by plugging those into here using our calculator, or just using plain old arithmetic. So 6 times 1/9, that's going to be 2/3 minus negative 1/3, so that's plus 1/3 minus 1, that'll be equal to 0. But that's okay. If we're confident in our quadratic formula, we can just use these and keep going. So cos theta is equal to 1/2, or cos theta is equal to negative 1/3. So this will illustrate exactly what I'm talking about. If we were to plug in 1/2 on our calculator and do the arc cos, or cos inverse of that, we'd get 60, but that's not the only one that'll work. negative 60 will also work. Okay? You have to sort of remember that, well, actually the easiest way to do it is just to remember. So this one's by calculator. So don't forget that cos theta is equal to cos of negative theta. Okay, that's a law. So if we have cos theta is equal to negative of 1/3, we can plug that in, and this one you'd actually need your calculator for. All right, we should get out a value of 109.47 degrees. I know that asked us to round to 1, and we'll do that in a moment. And the other possible one, remember that we can go negative, so the negative of that angle will also work. We're going to order these. I think they said round, but let's double check. Round each answer to 1 decimal place, so the 4, and then it follows by a 7. 7 means we need to round up. So we round up to negative 109.5, negative 60, 0 degrees, 60 degrees, or 109.5 degrees. Okay, we've got 1 decimal place going for us. That's all we needed. So 3 of these were the really nice angles, but then there was this extra case, and we did need our calculator, and we were happy we brought our calculator along. If for some reason you didn't have a calculator, I would suggest using graph paper. Draw a really big unit circle and try and figure it out from there, and use your protractor. But I really think the best thing to do is always keep a calculator with you. They're allowed as long as they're not programmable, so you might as well bring them. They can make your life really easy sometimes. Alright, so that concludes B part. Now for the C portion of the question. Determine all values of theta with 6 cos 3 theta, or so 6 cos cubed theta minus 7 cos squared theta plus 1 is less than 0. And we're still talking about that same range. Okay. So we know exactly when this polynomial in terms of cos theta is going to be equal to 0. But when is it less than 0? And I guess you could also ask when is it greater than 0. But the question is specifically asking us for ranges where we get the value to be less than 0. Okay. Well, fortunately for us, we already have it factored. I mean, we don't have it factored, but knowing that, we know that 1 is a root, we know that a half is a root, and we know that negative 1/3 is a root of this formula in A, will allow us to factor it a little bit, and we can go from there. There's a general technique for finding out when things are less than 0 or greater than 0. So we have 6 cos cubed theta minus 7 cos squared theta plus 1. We want that to be less than 0. Well, we can factor this as cos theta minus 1. And then we can do 2 cos theta minus 1. Remember, so 1/2 solves this. If cos theta is a half, it should get a 0. So 2 times a half minus 1 definitely should be 0. And 3 cos theta plus 1. So what we've done is we've factored this and we kept the cos theta in. And if we wanted to, we could substitute in A again. And I may need to do that just for space considerations, but we have indeed factored this whole thing. Okay? And we could go back and check. We know that this is supposed to factor as cos theta minus 1 times 6 cos squared theta minus cos theta minus 1. Well, we get the minus 1 there. We have the 6 cos theta squared, and then 2 cos theta plus 1 plus 3 cos theta minus 1. That should give us a minus cos theta overall. So this is indeed the factorization. So we have two cases when if all of these are negative numbers, then their product is going to be a negative number. Remember, a negative times a negative is a positive, and if you multiply a positive by another negative, we get back to negative. Okay. So if all three factors are negative, then the product is going to be negative. Or if one of them is negative and the other two are positive, then the product is going to be negative. Okay? Now we know when each of these guys hits 0. And you can't, they're continuous functions. So cos theta minus 1 can't go from positive to negative without hitting a 0 in the middle. That's just part of what continuity means. And so this is particularly helpful for us when they give us a sort of a polynomial like this, and then ask us when is it negative, when is it positive. What we can do is just figure out, okay, where are the roots? And then for each of the factors, the linear factors, when are the linear factors positive or negative? Okay, so I'll show you a bit more what I mean. So, negative 109.5 degrees, negative 60 degrees, 0 degrees, 60 degrees. I always set up a little chart like this. And cos theta minus 1. Is it going to be positive in this range? Is it going to be negative in this range? Or positive here? We'll find out. Actually, it's best if we... Let's do it this way. It might be a little simpler. So, theta less than 0 degrees. Theta equal to 0 degrees, and 0 degrees less than theta. Okay, so we know it's equal to 0 here. How about, is it positive or negative here? Alright, well, let's take a look. We could pick any old value, so maybe 30. So cos 30 minus 1. That's going to be negative in this range. Or sorry, negative in this range. I'm pretty sure it'll be negative in the other range, but we'll just double check that. And you can really try any. If you're not convinced that this whole range is going to be negative, try other values. Try cos 70 minus 1. That's still going to be negative. Try cos 166 minus 1. That's still going to be negative. It can only go from negative to positive if it crosses the x-axis. So if it had another root somewhere else. But this is the only root in our range. Alright, I guess we could add in those guys. How about for cos of a negative angle? Let's try negative 20 minus 1. Well, that's also going to be negative. So it appears that other than at the root 0, this guy is always negative. Right, the little abbreviation for negative. All right, how about one of the other ones? So 2 cos theta minus 1. So it's got roots here and here. That's negative 60 and 60. It's way too small a writing. All right. So theta less than negative 60. We know that it's 0 here and here, but how about in the middle of them? So you just pick any old value. By continuity, they're all going to be positive, they're all going to be negative. So I picked 30. Cos 30, well, I know that's going to be root 3 over 2, so this whole area is positive. Oops. Sorry, multiplied by 2 and minus 1. So multiplied by 2, you get root 3. Root 3 is greater than 1, so you still get positive values. How about in this range, when theta is less than negative 60? So try just cos of negative 61 and multiply that by 2 and subtract off of 1. You're going to get negative values here. And you're going to get negative values up here as well. Right? Don't believe me? Pick something. Let's say 77. Cos of 77 is 0.22. Multiply that by 2, you're going to get 0.44. Subtract off 1, you're still going to get negative values. So out at the extremes, it's going to be negative. In the middle, it's going to be positive. Okay? And that contrasts with cos theta minus 1. That's negative everywhere except its one root. So we have one more to go. 3 cos theta plus 1. Well, what are those roots? Negative 109.5 degrees and 109.5 degrees, approximately. We can drop off the function. That'll give us a little more space for writing our ranges. And yet somehow I am still running out of room. So we'll just go on to the next line. 109.5. We'll put him up here. Okay, so we know he's 0. This function is 0 and 0 here. But what about the intermediate ranges? So try 3 cos 100 plus 1. Well, we get a positive value in here. How about if it's bigger than? So maybe take cos 110, multiply that by 3, and add 1. We get negative values. And you'll get negative values up here as well. We could try taking maybe cos of negative 120. That's a value you might be familiar with. It's negative of a half. Multiply by 3 and add 1. You get negative of a half again. It's still a negative value. So to figure out where all three of them are negative, or one of them is negative and two of them are positive, we just need to figure out where these ranges where they're negative overlap. So this guy is going to be negative if theta is less than 0, and this one's going to be negative if theta is less than negative 60, and this one's going to be negative if theta is less than negative 109.5. So, I'm just trying to think how best I want to write it, because clarity is key in these questions. So, what I might do is make another chart. So I want to be absolutely clear. And we'll just make it a very big, long, multi-line chart. It's probably something I could have done at the start, but I didn't because I'm a bit of a goof. Cos theta minus 1, 2 cos theta minus 1, and 3 cos theta plus 1. And their product. So negative 109.5, and then the next one is negative 60. Negative 60. Negative 60, and then theta, and then less than 0. 0 degrees. Alright, so in this range, this one here is negative. This one here is negative. This one's negative, so the total product is going to be negative. At negative 109.5, these two are going to be negative. This one's going to be 0, so the product will be 0. Same with down here and here. Alright, and in this range, well, this bottom one's going to be positive. Still going to be positive over here. Positive here and positive here. Okay. But this one's still negative, and this one's still negative. Negative, negative, positive, positive. So negative times a negative times a positive, well, that's going to be positive. We don't want this range. Negative times a positive, that's negative. So theta between negative 60 and 0, that'll give us the total product, that cubic formula in cos theta. That product will be negative in that range. All right, we can continue on. So 0 less than theta less than 60. 60. 60 less than theta less than 109.5. 109.5. So we can fill some of this stuff in. Positive, negative, negative. We can just go back and reference our previous charts if we need to. Positive, positive. So negative times positive, that product's going to be negative. That's 0, that's 0. A negative times a positive, that's going to be positive. So once again, we don't want this range. And we have one more range to go, and they'll all be negative here. If you don't believe me, go back and check our little charts. So 109.5 less than theta. It's really less than or equal to 180. I just can't remember what exactly it was we said. So this is negative. This one's going to be negative, and this one's going to be negative. So the product will be negative. So for our final answer, we're going to need to actually check, is it less than 180, or is it less than or equal to 180? So it's definitely less than 180 and greater than negative 180. Okay. So we can go back and refer to our big chart rather than chasing down little details in the small chart. So this range, negative 60 degrees, less than theta, less than 0 degrees. Uh, 0 degrees, less than theta, less than 60 degrees. That's also in the range. And finally, negative 109.5 degrees, less than theta, less than 180 degrees. Okay. And if we wanted to, we could check. We could pick a random number in these ranges and double check by plugging in the cosine and cubing it and multiplying it by 6 and everything like that. We can just verify our work that way. But thanks to our smaller charts and then combining them into this larger chart, we know exactly when each of the individual linear components is negative or positive, and we know how that affects the product, so we can definitely tell when the product is positive, negative, or 0. Okay. So it seemed a little lengthy, but our charts were clear, and they expressed exactly what we wanted to. We read off the ranges rather quickly, and that gave us the final answer, which is all we needed to finish off question number 2. So if you liked that question, leave a like, and as always, you can subscribe for more contest videos or more math content in general. If you like the math enrichment videos, I got plenty of those. And then there's also delving into actual mathematical subjects. So subscribe for more content if you want, but either way, I'll see you guys for the last question, question number 3, in the next video. So thank you all for watching.